Hi everyone. Hi everyone. Welcome back to the channel called Engineering Beyond Blueprint. As we explored in our previous videos about the definition of passive component and different types of passive component and their critical parameters, right? Understanding how these critical parameters are differs and which one is better when we are going to select the alternative solution for given component, right? So with that said, I had got a lot of requests that from the viewers that we have to get deeper into understanding what are the possible or potential interview questions expected, right? So with that said, like I was segmentized to betterment for everyone, starting from junior to mid level engineer to the expert level senior profession. So this is going to be help for them when they kind of attending the interview to crack the interview or to fulfill the role requirement when it comes for interview process. So with that said, let's get started with out recently and getting onboarded for component engineering role. So in total, we could expect around 50 frequently asked questions in most of the interviews. Let's get started with question number one. What are the passive components? So passive components by default, as you know, they do not generate the energy. They only store, limit, and transfer the energy, right? So example of passive components are resistor, capacitor, transformer, and inductor. So to understand the definite question, a resistor limits current to protect an LED, right? Next comes difference between resistor, capacitor, transformer, and inductor. So as you know, resistor functionality is to oppose the current flow, and capacitor stores the electrical charge, and transformer transfer the electrical energy from one circuit to another circuit using electromagnetic inductions without electrical connection, right? Likewise, inductor functionality is store the energy in the magnetic field. Example, in power supply, resistor is used for current limiting, capacitor is used for voltage smoothing, and transformer used to convert the AC voltage, like example 230 volt from the primary to transferring to secondary as a 12 volts. Inductor is used for noise filtering. Next comes why passive components are critical. Answer is like they ensure stability, safety, noise control, and signal accuracy. Example, without capacitor, DC power supply will have ripple and unstable voltage. What is resistor tolerance? The tolerance shows how much actual resistance can vary. It could be in plus or minus 5% if you consider as a 10k ohm resistor. So it could be somewhere between 9.5 kilo ohms to 10.5 kilo ohms. What is power rating of resistor? Answer is like maximum power a resistor can safely dissipate without damage. Example, using 0.25 watt resistor is an 1 watt application, causes overheating and failure. Types of resistor. There are three types of resistor mainly we categorize. One is called carbon film and metal film and wire wound resistor. Carbon films are cheap and low accuracy, whereas metal film are stable and accurate. Wire wound are resistors are widely used in high power applications. For example, wire wound resistors used motor braking circuits. Why polarity of capacitor is matters? Answer is like electrolytic capacitor having polarity, reverse the connection, damage them, right? For example, if reverse the polarity causes bulging and leakage. What is inductance? Inductance is a ability to oppose the change in current. Example, inductor resists sudden current spike in SMPS. 11th comes where are the inductors are used. The answer is like filter, converters, and EMI separations. These are the places the inductors most oftenly used. Example, a bulk converter uses inductor for energy transfer. Next comes DC through inductor. Inductor behaves like a short circuit after steady state. Example, DC motor inductor allows current after startup. What is a transformer? Transformer is a passive electrical device that transfers the electrical energy from one circuit to another circuit using magnetic induction without electrical connection, right? So for example, a 230 volt has been passed through the primary secondary coil, it is converting into 12 volt, right? So why the transformer called passive component? Because it does not generate the energy, it only transfer the energy from input to output. Example, the phone charger transfer only the step down voltage, it does not create power. What is the main parts of the transformer? Primary winding, secondary winding and magnetic core. These are the main parts of the transformer. Example, copper winding wound around in the iron core. What is a step up and step down transformer? Step up increase the voltage, whereas step down is decrease the voltage. Power transition use step up transformer. What is a transformer isolation? Electrical separation between input and output for safety. Example, isolation protects the user from main shock. Now getting to the middle level engineers who are falls under 2 to 5 years of experience, the questions would be something like this. Resistor selection for power circuit. Yes, of course. Check resistance and power rating, temperature rises and derating. Example, if calculated dissipation equal to 1 watt, the Q should be always greater than or equal to 2 watt as a resistor. What is a TCR? It's nothing but a temperature coefficient resistance. If anything changes in the resistance with the temperature, right? So that is how we are going to measure the TCR. For example, precision ADC circuit needs low TCR circuit. Why capacitor value changes? Capacitor value changes due to the temperature and DC bias effect. Example, 10 microfarad X7R becomes 5 microfarad at rated voltage. And understand what is the difference between three dielectric material called COG, X7R and X5R. COG is stable and accurate, whereas X7R is good in balance and X5R is smaller and less stable. Example, trimming circuit use COG. What is a ESR? ESR is a equal series resistance. It causes heat and ripple losses. Example, high ESR capacitor overheats in the SMPS. Next comes effect. Example is like if there is an excess ripple, reduce the capacitor life. Example, to underated capacitor fails early in the power supply, right? Next come saturation current. What is mean by saturation current? Current where the inductor lost the inductance. For example, exceeding the saturation causes voltage instability. Next comes, what is the difference between ferrite and iron core powder which is used in the transformer, right? So answer is like ferrite is high accuracy whereas iron powder is DC bias tolerant. Example, bug converters use ferrite cores. Next comes effect of DCR. Answer is yes, higher DCR, more losses, lower efficiency. Example, lower DCR inductor improves the efficiency. Why parallel capacitors are important? Answer is like lower ESR plus wide frequency filtering. Example, if 1 microfarad plus 10 microfarad near to MCU. Marginal voltage rating. What is mean by marginal voltage rating? Reduce the lifetime and reliability. Always derate capacitor voltage by 30 to 50%. What are the critical parameters of transformer? Answer is like turn ratio, voltage and current rating, power rating and core material which is used to make the transformer and frequency. Example, 50 Hz EI transformer differs from high frequency SMPS transformer. And next comes, what is the transformer efficiency? Answer is like a ratio of output power to input power. Any efficiency which you want to be measured, it's always division of output to input power. Example, high efficiency transformer wastes less energy as heated. Right. Next comes difference between iron core and ferrite core. Iron cores are used under lower frequency application. It is something around between 50 to 60 Hz. Ferrite core higher frequency applications is used and is mainly used in switched mode power supply. What is a transformer regulation? Answer is like change in output voltage from no load to full load. Example, poor regulation causes a voltage drop around the load. Why transformer sometimes it make a noise saying hum, right? Why it is make a noise? Due to restriction in the core. Example, old adapter produce audible hum. What is the leakage inductance? Answer is like inductance due to imperfect coupling between the windings. If there is an improper coupling across the windings, then it causes a leakage of inductance. Example, leakage inductance causes voltage spikes in switched mode power supply. Next comes to the senior and lead engineer level, which is there have been around 5+ years of experience. These are the expected question during the interview. And the first question would be like capacitor derating. What is mean by capacitor derating? Answer is operating below max rating improves MTBF, right? Example, 50 volt capacitor used 25 volt last much longer. And next comes DC bias derating. Why DC bias derating happen? Because a capacitor, especially in the ceramic capacitor, losses capacitance under DC voltage. Example, designer compensate by choosing higher nominal value. Now next comes for trade-off. Trade-off is sometimes asked in some of the interview questions where they want to understand when we are selecting the component, we have to be see the cost as well as reliability. So when it comes for this kind of situation as a trade-off, we need to understand if the component size is smaller, going to create higher stress, whereas lower ESR at higher cost. Example, automotive uses larger and safe components. Next comes, what are the electrolytic failure modes? Answer is sometimes the capacitors kind of dried out and leakage and due to ESR increase. Example, old SMPS fails due to dried capacitors. Why MLCC sometimes it get cracks? Answer is PCB flex and the thermostress. When there is a thermostress, obviously they be on MLCC going to be crack. Use the flexible terminations for MLCC. Next comes, what is failure analysis? During the visual inspection, ECR test and X-ray, we can find those failure for component through these parameters. Example, swollen cap indicates over voltage. Next comes automotive selection. There are different trade-offs and grades which we use when it go for automotive selection. One is like as I said, AEC Q200 resistor is used in electrical vehicles. Passive tolerance impact. See, passive tolerance, why the passive tolerance getting impacted? Answer is effect gain and offset and accuracy. Due to these three parameters, there is a passive tolerance impact. Example, op-amp gain error due to resistor tolerance. Next comes EMI and EMC impact. Answer is incorrect passive causes noise emission. Example, wrong capacitor placement increase electromagnetic interference. Next comes difference between power transformer and SMPS transformer. Power transformer are like used in low frequency applications. SMPS transformer use high frequency applications. And power transformers are larger in a size, whereas SMPS are in smaller in a size. and to make the power transfer use the iron core, whereas SMPS transfer to make by using ferrite core because it's required high frequency application. Example, the laptop chargers use SMPS transformer, right? What is a transformer derating? Answer is like operating transformer below rated power to improve life and durability or reliability. Example, using 100 volt amp transformer at 70 volt amp. Transformer, what are the failure modes for the transformer? Answer is there is a insulation breakdown and core saturation and overheating. So these are the possible of transformer getting failed. Example, blocked ventilation causes winding insulation failure. How does transformer affect EMI and EMC? Poor winding layout increases electromagnetic interference. Example, shield welding reduce the common mode noise. There are certain safety standards. What are those safety standards which used in a transformer? So as you know, IEC 61558 and UL and CE define insulation and creep pages. Example, medical transformer requires reinforced isolation. Next comes transformer selection for SMPS. So what are the parameters we have to consider? One is obviously, as we discussed, switching frequency and core material, isolation requirement and leakage inductance. Example, flyback transformer in 65 volt adapter. And the last one comes, why transformer avoided in DC system? Because transformer requires AC to work. Example, DC to DC converters uses inductor instead of transformer. So with that said, I have been covered most of the frequently asked questions during the interview process from junior to senior level. I hope this video or this entire tutorial is help a lot for you to get prepared for interview. With that said, thanks for watching this channel, and I hope this is going to be help a lot for the ones who are seeing this video. And share me your feedback so that I can improvise further if there is a need. And with that said, thank you so much for watching. Have a great day.